Okay, we were almost, we were I think slightly over 1 hour, so that's fine. So we got the roads here. We got our some random points. So the next thing we want to do is, I'm going to put a null here. I'm going to make this one a bit better than my current biology simulation version. So these are all my curves, right? I'm going to call this out curve. Okay, and then I'm going to put bring in my cars here. Object merge. Let's maybe line up like that. Let's say in cars. So into this object, pin it. So let's go into our cars here and drag and drop this guy here. Let's dive back inside the roads. Okay, and then what I want is I remember why we created this size attribute, because this actually we want to rename it to mass, but doesn't matter, we can use an attribute rename. And then let's rename the size to mass because it's based on the bounding box anyway. Now the next thing you want to drop is the crowd source node. Left side is for the agents and right side is for custom surface. So in, out, and if I look now, it's gonna give me some randomly distributed cars. Now if I select crowd source, I want to change some of these parameters to, let's say 100 by 100, and then number of agents. This is like those points, so 500. This is the part where we need to start getting random cars, and that's gonna be under randomize. So what we can do is to create enable this randomize agent primitive, and we can say custom distribution, yes, and then I can say, for example, agent 1 I have X amount, agent 2, agent 3, agent 4. Why? Because maybe I don't want so many buses, maybe I don't want so many police cars. It's a bit better way to distribute than going completely random, I think, because after all we're not gonna have so many variety of those. And then from what I can see, it's, sorry, I'll start from here. Agent 1 and 2 is my bus, and I think my police car is the last agent as well. Let me see. If I put a blast here, that's how I can tell what I want more, what I want less. So that's 0, I obviously want less. So 0.2. 1, it's another bus, I want less. 2 is a car. 3, 4, 5, 6. Okay, so 7 is a police car, so I want 7 is 8. I think this one is agent 8, so I want less of that as well. Don't want so many police cars around. I mean, we do, but we don't. Okay, so crowd source, back to the crowd source. So now it's a bit more randomized and it's all lined up as well appropriately, which means now if I end up fender bender like this, I can still use a relax 3D node, disconnect, and I can still push the cars a little bit further than each other, I think, by, oh, we did too much, I believe. No, don't want that much. Maybe 12. It's probably too much now. Okay, something like this. It will split anything that has been on top of each other. I think that should sort it out like that. So okay, cool. We have a layer of traffic. Can we split more? No, it's too much. That was nice. Okay, we don't need more. Yeah, that's fine. Okay, so now this is our crowd source. Crowd source. So what would happen if I end up turning this on? Is gonna get a lot more cars on every floor, but then each floor is going to have less amount of cars. So that's because it's not taking into consideration about how many times you're duplicating this. Since the cars will not switch height, so it's probably better if you just simulate each layer individually, just to avoid any speed issues that is not necessary, which we can deal with, which we can probably do with PDG anyway. Okay, so the other thing that we probably need to be aware is because as we increase more, it's going to spread more. As it spreads more, it's going to start getting inside the buildings more. So probably we don't need so many cars, or we need to remove some of them from entering the buildings, etc. Obviously, it's the first frame. We have collision avoidance, but it's probably ideal not to have them colliding already. So let's bring this guy here. I think it's time we save it now as a 04 city traffic 1. Okay, so now what we can do is maybe we change this to, we can put a .NET here. So just dropping a .NET network here for the traffic simulation itself. Let's rename this to, I guess, something that makes sense, which is a traffic sim. Traffic sim. Dive inside and drop in a crowd source. A crowd solver, and then we can plug in crowd source to here, to the sorry, not here, here, which is the crowd source, and we can plug in the crowd object. We can drop in a crowd object, plug into the left input. And then we're gonna bring in our state, which is the crowd state, which is by default walk. Oh, not the last one, sorry. Here, this one is the crowd solver. It's bringing in the state. So if they're going fast or slow, if they're braking, if they have different like sit, run, walk, but ours is just one state, which is just go. And the only affected thing is the speed. Turn off the retime clip to match the particle speed, because we don't actually have like a moving joints that are cached out or something. So we're gonna put a pop steer path here, and let's plug it in, and it's going to have, the path is going to be our curve force, so which is our, let's go into the roads, out curve, so drop this guy in here. Let's go back inside. It's going to be a curve lookup. Yes, my default size is for scale 600, search radius is 1000, and I am going to change this to a crowd steer force. Weight is 1, and I don't want to ignore mass, and then I'm going to put a little expression here. I want to randomize path variance, which can be found in, like, this is actually a preset. You can just go randomize path variance and force per particle, but let's see what it does, because we're going to slightly change it. It based on the point number, it kind of changes the force scale, and it gives a variance, so you by 5, so it's not exactly on the curve all the time. We're gonna leave that one as it is, but we're gonna change the force scale based on, we're gonna plug it into like we're gonna connect it to basically to mass. So PT num is gonna create a random value, and then we're gonna fit that to a certain value. So which is, so put a fit at the beginning. Again, these are not strict rules, so I'm changing it from 0 to 1. Oh, sorry, we need a comma here. So by default, the random gives 0 to 1, right? But I don't want to carve it at 0.5 for scale. I want everything to move. So I make my minimum 1, 0.5. I then multiply that by 10, and then I multiply that by mass. Okay, and then I'm gonna put in a pop steer wander. Hence the name. They're just gonna wander around, I believe. This is again set to crowd steer force. I don't want to ignore the mass. I want a 2D wandering. So I think this one allows them to get out of their way a little bit. All the relative information can be found here. This is a crowd behavior node. You can also use regular practice. This node has a force parameter which controls base and speed of wander, amplitude, yada yada. Apply forced agents, particles to create random motion, which is what we want. On XZ plane, and swirl size 10 meters. Swirl scale is the same. I put a pulse length to 2, so it's like every 2 seconds they kind of offset, so they don't just wander around too much. So that's fine. And then pops. Now went back. Now pop separate. This one is kind of like a collision detection. Change the crowd steer force as well. So force scale is how fast they change, how fast they slow down, and their field of view, and then the search radius. So it's kind of like a looks around pretty much. And then finally pop steer obstacles so they don't bump into buildings, which is supposed to be our bounding box, but we need to probably change it to bounding box because our geometry is quite heavy now for this. But I'm going to disable this for now to see what our simulation will do actually. So I suppose now it's time for us to update our frame ranges because we want. I made a big practice of setting my frame range starting from 1000. It's just to avoid complications with the amount of digits. So let's change the start frame to 1000 as well. So if I dive inside and hopefully put everything in auto mode, it's gonna cook. Oh, we forgot to plug in our crowd source. So there's gonna be all geometry, and impulse activation is the first frame. Obviously we don't want to spawn cars, but you could if you wanted. And then go back inside the roads, and then let's plug in our crowd source to the sub. I believe that's all there is to it. We could probably plug this to initial geometry anyway, but that's probably fine. So let me see now. Okay, so I have my cars here, so they should try to follow the road. Are they moving? They're moving really slow, and they're all going in the same direction, so we're missing something. Or they should turn actually. Okay, we're missing something. Something is not working. Let's check at the crowd solver. So particle motion, yeah, we didn't. Okay, turn on the project forces. So if enable force will project the plane defined by agents affect. So we don't have a plane. I don't think there is anything else difference here. Let's go to avoidance. Enable avoidance. So enable the force that causes agents to avoid each other based on anticipated time to collision. This is, I think we are taking care of that with pop steer separate. So I'm going to turn that off, and sub steps. Time scale 4, yeah, because we want this to move a little bit faster. Okay, let me see now what's going to happen. Okay, something is still off. I wonder if it's something to do with the steer path. Are we missing an attribute curve? Look up, reverse direction maybe? No, we're missing an attribute somewhere. Okay, well, this looks correct. It's just that, is it the, there's an error here. value state point attribute not match known state woke. Okay, so maybe something to do with our crowd states. We don't have the name. Okay, I'm gonna pause the video. I'm gonna cross compare with my other scene, and we'll get back again. Okay, that was a stupid mistake actually. It was because the state name for the our crowd state was not woke. By default it's crowd state, and then because our state name is set to $os, which is coming from our source. So if you go to our source, here is our initial state is woke, and then it wasn't able to find it, obviously, because it was looking for the state crowd state. But if we change the woke, it's just gonna work better. It's gonna find the state. So but the other thing I did right in between is because I was trying to debug it faster, so I just select the little section here, which I'm gonna select the bigger section now for testing purposes. Somewhere I think like this should do the trick. Just delete none, so you get like this network here. And the other thing I did is that change the heading to normal here, but that shouldn't be important, like, because we're gonna give them some time to settle. So if I now press play, maybe change the background to dark so you can see the cars. So if I press play, we can, I think, increase the amount of cars a bit more. So let's go back to roads and our crowd state. Now let's go maybe 200. Is that enough? Yeah, that's 200 cars. Okay, let's go back inside the .NET. And let's press play. And they'll kind of try to avoid each other to crash. That's where we need to play with the settings. And it's like they're not really doing a good job. But there is kind of like, if you just look, there's kind of like some traffic going on. And we didn't even randomize so much. They wait for each other. It's just that when they turn, they're not very good, I guess. But we can further optimize these settings, obviously. Pop steer path, maybe we can actually, let's try the avoidance, because I am not sure if it's gonna make a big difference, but I think they still go through each other. I think this is the same. If we dive inside and find this section, actually, post-sol, ragdoll setup, crowd source, enable crowd solver, because it's our solver, wipe transition, steer weight, steer force. Where do we have pop steer avoid? I think pop steer solver, pop steer avoid. I think that's the, yeah. So that's the same section as this one, I believe. Pop steer separate, pop steer avoid. Okay, this is the one we're missing. I'd like to investigate that. Steer avoid. Let's go to the first frame. Let's drop that in as well. So I'm just gonna turn these off. Just gonna keep the steer path on. Actually, I'm gonna keep this off as well, and this one. So they should, everybody should just pass through each other now, which they do. So they don't want that. And I know that this kind of works. Let's see how this works. Pop steer force, particle scale, force scale, anticipation time. Let's go 2 frames. Okay, let's press play. So they're kind of like trying to steer more efficiently, but still crashing into each other, I guess. Weight, particle scale, not necessarily. Let's go 2, force scale 10, neighbor distance 20. Let's put 30. This should maybe do any good. Oh, so that's what happened. Kind of like it just jumped out. That's what it's doing, kind of, but it's not really. It's not very smooth. Kind of like a speeding up. So let's go 4 scale 1. Let's see if that kind of does anything. No, still catapults them. Okay, I'll have to investigate that one a bit more, but I think so far these guys are doing a better job. Pop steer separate, so we can go braking force maybe. If we go 4 and maybe radius 40. Okay, they do a better job now. So I'm gonna pause here now and prepare for the rest of the sim. Actually, no, actually we can, I guess, just do a test with the whole network. Okay, this guy is here, so we can then make sure that we have enough cars. So we're gonna go what, 1,000? I think 1,000 is a bit too much, but then it's a polluted future city. I don't know, maybe 700. Okay, and then I guess we can dive inside. Go to the first frame. So without the building collision, it's kind of quite fast. So as long as they don't go through the buildings, as you can see, it's pretty actually cool. There's a lot of traffic there. Oh my god, this looks like Istanbul. Nobody's going anywhere. That's a lot of cars and not enough roads. So I think we need to drop the number a bit more. Obviously, because these roads are not going anywhere. So let me turn that off so you can see it a bit better. Let's go back into the roads. Okay, like again, these numbers are up to you people. Amount of cars, the size of your city, these are all relevant to your setup. But I think now there's a bit more space for cars to move. Yeah, we're gonna have some traffic going on. There's some traffic jam. I wonder if we could squeeze them more inside, separate for scale, braking force. If we put one, are they gonna get more traffic? Are they gonna get closer to each other? I think they do. I think that's fine. Okay, so in the first version, we can, because we don't have the building collision yet, what we can do is definitely turn off our single pass so we get all the roads. Okay, and then so we have like how many? 5. So we can go 5 times the, so what, go, let's say let's go 2,000. I think that's probably fine. And maybe it's a bit too much, I don't know. Let's go into the traffic sim, and if you press play, I just want to see how slow it is. So let's go, show time is on. Let's press play. So it's pretty good, 4 frames per second. So you know what, let's cache it out. Let's go back into the roads. Now we're gonna put a DOP import to bring out the traffic simulation back to SOPs. So that's a .io. So we can here define from where what we want to get. So .network becomes .node. I guess we can get the full path. And then in there we have the crowd object, which let's actually call it cars, and thus we need to go in there and then call this cars. Back in the roads, it's the import traffic, and then I want to get rid of a lot of attributes that I really don't need. If I go first, let's see if this is working. We need to change the what we want to bring. This needs to be explained. So what I want to bring is the geometry of cars. So object cars, geometry. Okay, so that should bring in the geometry. 2,000 cars. are here. So then what I don't want definitely is a lot of these attributes, which I don't need them anymore. So that in that case, because it comes with like how many neighbors I have and this and that, and we really don't need that anymore. We just need these cars that are here. We don't need these spheres too, but that's fine. We can investigate that a bit better after. Can we separate that? No. So attribute delete. Unpin that. What I don't need is everything but ID and velocity, and actually agent name in case it might come handy. I don't need this. I don't need this. I don't need this. Okay, I have the unique agent names. I have the agent IDs, etc. So I can copy back the original models back on these, and then I want to now cache this out. File cache. Traffic sim. So because we did a little bit of a custom workflow here, I mean, we're gonna replace these objects with the wait a second, I think we're losing one important attribute, which is orient, for obviously orienting back on the original models. We are gonna need a p-scale. I think, I mean, they're all 1, so we don't need it because we're not scaling the cars, which we could. Just create a little bit more randomness, but life, we don't need state, we don't need pretty much any of this. Let's get the up vector as well. Okay, so we have the up vector as well, have orient, that's all good. So now traffic sim is gonna go into, well, traffic sim here. So let's remove the heap name, my folder name, and my frames. File save. And I want to cache this out for what, 1000 frames? I don't know if we're gonna cache it out. Let's cache it out for now for 200 frames. Okay. Let's get a simulation for 200 frames and hit save to disk. And it's gonna cache that out. Okay. I'm gonna stop it and then we can watch it after. Okay, so the simulation is finished. These are all my cars moving around for 200 frames, tirelessly trying to get back home. If we look from somewhere like this, I guess if we press play. Okay, let's bring in the city, I guess. If you look from the top view, without the, and then let's create a little play blast. Of the book, I mean, sorry. And just like in real life, there's a lot of little accidents and everything, but don't forget, this is not a crowd tutorial. This is just so we get something more interesting, something a bit more alive in our tutorial. Once we render this, is exactly what I have in my tutorial promotion video as well. It's just adding a lot of life to the objects. Okay, what we can do to speed this up even more is, what we can do for rendering is the part that where we will instance these objects back to using our agent name, or yeah, pretty much using our agent name to do a match, and then copy the points back onto the copy the vehicles back onto the simulation points. So if I actually put an add SOAP here, I can get rid of the mesh, and all I have is now the points, but moving points. And they have orient and they have an up vector. So now all I have to do is write out these guys into disk from our traffic node, which I can go here and then call it in cars. So remember, we have all these guys here, agent 1, 2, 3, which is with 0, 1, 2, 2. So I can put a Redshift proxy output, okay, and basically I can do a blast based on, because I have 0 to 7, so I can say cook from frame 0 to 7, sorry, I think 0 to 8, 0 to 7, yeah, actually, and then just put a $F and remove what I don't need. So if I go to frame 0, it's only going to give me one vehicle, which is agent 1. So if I go to 2, 3, 4, yeah, there, that. Okay, actually let's go from maybe 1 to 8, just so it doesn't get confusing. We'll need to put a proper name here. I always put this in properly. So we can go to geo. Remember, we had our models obj. We're gonna call it cars rs proxy, like to do everything, and then it's gonna be $F dot rs proxy. And if I run this guy here, it's just gonna switch each one of them using the $F, and it's gonna write out our proxies here. Now all we have to do is to instance them back. And this one, the last one, seems to be empty. 0 to 8, so supposed to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 1 to 8. That should be correct. It's just a bit suspiciously small. Okay, so which means we have our path. So let's copy this path. Let's go back on cars. Oh, sorry. Back on roads. That's where we bring in the cache, right? And we cached it from, it was 1000 to 1200. And now we ditch the geometry, and then we're gonna instance back. Basically, we just need to create use the agent name to replace our rs proxy string. So for that, what we were using is printf. So if I go here and then say s at instance file equals to sprintf, then I put my path, and then I put my s at agent name. So this obviously doesn't do anything yet, but does an error as well because it creates an instance file attribute, but it's always going to be 0. So now what we want to replace is that we want to replace the 0 with the agent name, which is going to result in our proper file path. So that's %s. So now agent7.rs proxy. So if I go to my folder, geo, actually if I can just copy this and see if it's going to resolve properly. And oh, that's not exactly what we were supposed to put 1, 2, 3. So it's the wrong name. So let's agent and then the number. Okay, so let's delete this. Let's go back to cars. So here then we want agent.ref. Okay, render to disk. Let's check the folder again. Now it's agent 123, and this should be also correct. Agent 123. Okay, so now that looks correct. Let's go look from our city LookDev camera. We have our traffic here. Let's go to our, now because it's a RS proxy, we need to put an RX proxy sub. Okay, and then if we go to our out network, hopefully it's gonna work. Let's duplicate this, but this time I think, okay, we probably should work a bit more clean. Let's call it traffic RS, and let's probably just, oops, null. Let's call this RS instance point. Let's plug this in traffic RS with an object merge. Okay, where is our node? Is here, nodes, and then let's drop in the node in there, the proxy node, proxy Redshift proxy sub. Okay, and this is black. So if we go out again, city render, let's say traffic render. Okay, and objects. So we just want to check the traffic now to see if it's working. Traffic RS accept. Is it gonna work? I have no idea. Let's see. And it works. The orientation is correct and renders quite fast. So let's even get closer. Maybe with the building LookDev. Different camera, something like this. Well, obviously we want to see where we're looking to see if the cars are in the correct place. So for this we can load this guy. These are still packed, so it should be fine. It's just so we can see what we're supposed to see, so we can QC it pretty much. So let's render something like this maybe. From building LookDev, traffic render. So we should have these cars up there. And it looks about right. I have one car. I have another one there. Are they all same? No, they're not all same. I'm not entirely sure if this is absolutely accurate, but I don't think it is. But it looks correct. I have a bus there. A lot of cars. Okay, so I guess we need to see. And then, so I think now let's go back. Just put another render with the city, with the cars visible, just to see where we're going with this. So this was our road. This was our visible buildings. Otherwise, these are our cars. Let's put this in another geometry, and let's call this traffic system. We still need to create our boundaries so we can avoid for buildings to collapse into our buildings, cars to collapse into our buildings. Let's call it traffic system. Let's give it another different color just so it's not the same. These are the lights. Lights are bright, yellowish. This is more appropriate for lights. This was fine for rendering. Okay, landscape. We need to give some life, some love to our landscape. It's at the moment still gray. We don't have a shader. I'm going to save out, so we don't need this anymore. City render. We can put the cars back in here. RS building RS proxy building RS traffic RS. Okay, so let's hit render and see where we are at. Maybe a little bit closer. Let's get a bit closer. yes, something like this is a bit more interesting. Okay, I did save. And let's hit render. See where that takes us. So yeah, so this is now how it looks like. I also did a few more tests just in between after this frame came out, just animated this camera in different parts of the city. And then these were the results. So these are the raw renders. Top-down view, a bit closer up, which tells me that we may need to put something more interesting on these floors. Something like, I don't know, something a bit more interesting, like maybe boxes to resemble some kind of structure down there. This is not so bad. Remember, these were like quite low res textures, so I guess we can. There's a lot more. There's a lot of room for improvement. So yeah. So these are the raw renders. This now concludes the city making and the traffic version of this tutorial. What we can definitely do is to bring out some more interesting AOVs, like I don't know, reflection and refraction, and then do a little bit of comp to create something a bit more fun to look at. So thank you for watching. Now what we are going to do for the rest of the tutorial is the part that, if I can bring my master scene on this side, is to, so basically now we completed pretty much up to here, except this camera section. So we have our environment lights. We did not this part, sorry. So we did our traffic. We have our other models that we're gonna look into, which was our spaceship. So it should be, where is it? Here it is. Our fighter jet, let's call it, which we are going to set it up, which I'll explain all those here. And then we are going to, if we look from the chase cam, bus crash, enter, where's my chase cam, record, pilot, look there, okay, guns rear. So if I turn on these my ships, this is showing it, looking at the back one, flight cam, yeah. Let's bring in the terrain as well, which is the part that I need to show you how to add the textures. And this is what we are going to do next. And the build and bounds that I was talking about was this, so which we need to improve our collision detection, etc. And what else do we need to show you is that how we are going to use chops to edit our recording of our gamepad controlled path, and then how to record using a gamepad, how to record keys using a gamepad or a keyboard. The other thing that we're going to do a little walkthrough is how to create this automated shooting rig, which was here, should be guns. So if I play, boom 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 boom, this is where the explosions I think happening, and then yeah, the automated shooting rig. Let me maybe switch back to pixels so it looks a bit clearer. Yeah. And yeah, so that's now the dynamic part. Now we finished the city part. So feel free to put your cameras anywhere you want, and then from there you can just generate anything you want. There are a few things that I want to recap before actually ending the video, which are quite important, so you don't go through the same mistakes I made. Make sure your linking attributes and paths for all these proxies are good. By that I mean, you know, the file paths that are always loading the proper objects and proper textures. The other thing that please make sure is that you actually have a clean building geometry from the city source. So whatever you have here, inspect them one by one to make sure that you don't have some rogue polygon that is stretching to infinity. That's why I also put this one here just before I pack my building. Let's call it, actually, let's give it a name. Kill, delete, or remove, delete infinite polygons, which is basically anything bigger than 1000, 1000, 1000 bounds. It's just removes. Remember, it usually does an extrusion that goes to a super high value, and it's always a 1 polygon. So if it's outside of that, it's just gonna clean that up anyway. The other thing that I find that works more is that having not so many lights on does kind of give a bit better look. That's the part when we load the buildings, right? So we split them after we load each one of these buildings. Remember, we split them in office lights, in building, etc. What I found out that works a bit better is less is more. In this case, what I'm doing here is that I have a delete sub. So originally I have 2479 lights, and then I kind of dropped that to half, and then create a few random ones, and then just give them the colors that we were doing. Copy the points, and not so bright works better. So I think that kind of is working fine. I mean, we can probably change the value of the where was it, on the material. So our current emission weight is 100, and that's how our buildings end up rendering. There's nothing else I can really think of, so that's gonna be the first part, and then from the next lesson we will start doing our dogfight scene. All right, thank you for watching again.